Namaste everyone. Welcome to the CET classes and especially current electricity. Today we will start a new idea, that is finding out the equivalent resistance. We will start from smaller and smaller topics or circuits. Then finally we will go to the complicated topics, then we will solve it. So there are some rules and there are some ideas, there are some techniques in solving the complicated resistive circuits to get the equivalent value. Once you study the resistive circuits, of course you can apply to capacitors also, no problem. But that idea has to keep in mind, and your brain has to train with all those ideas, techniques. Then it will be very easy. So we will start with simple circuits and then we will go to the complicated one. So what are the techniques involved in this? What are the shortcut ideas? We will see that one by one. Okay, I will send you all these circuits. For the time being, you scribbled in your notepad. So be with a pen and paper. Without that, don't watch this movie, because this movie is a very bad movie with only one actor in that, and that too a very bad actor. Okay, so better you treat it as a class rather than a movie. Because if you expect people like Yash or Puneet or anybody, nobody will come here. No hero, no heroine, nobody. Only one character. So treat it as like a class. So be with the paper and pen. Start writing down. Start scribbling down. Now this is a circuit. I want to find out the equivalent resistance. Always equivalent resistance will be asked between 2 points. A circuit will have many nodes, many points where the electrical components will be connected, especially the resistors. Now, when they are connected, it will have many nodes and many junctions. You will be especially asked to find out the equivalent resistance between 2 points. And those 2 points should be the points of consideration. You must be, at any cost, you shouldn't lose those 2 points. For example, in this circuit, if you are asked to find out the equivalent resistance between, what is the equivalent resistance? Equivalent resistance between okay, A and B, if it is asked. The meaning is you must connect a battery across A and B. That is the meaning. You are going to connect a battery across A and B, and when you connect a battery across A and B like this, say, the current from the battery will split into 2 parts here. It will branch into 2 parts, and here it branches into 2 parts. Now, whether this current branches into some other part here? No, because there is nothing other than D. So D is simply a point. There is no connection afterwards D. So all the current should pass through this R, and there is no connection here onwards, and there is only connection here. So whatever the current flows through this will flow through this and flow through this. That's why these 3 resistors are in series. Now, when you look at the circuit between the points A and B, right? When you look at the circuit across A and B, the meaning is you are imaginarily connecting a battery across that. When you connect a battery across this, these 3 come in series, not this one. This comes in parallel. So, and another point you have to remember is, when you write the equivalent circuit, you are not allowed to lose the points which are asked. So you are going to find out what is resistance across A and B. These 2 points shouldn't be lost at any cost. You may ask, sir, I get so many ideas when you look into this circuit. Sir, if I hold it here, whether these 2 are in series, why can't you treat R and R in series, this one and this one? Of course, you can treat it, but not now, because if you treat these 2 resistors in series, same current should flow through them, right? 2 resistors are said to be in series if the current flowing through the resistors are same. Now, when you connect a battery across A and B, if you are asked to find out the resistance between A and B, then current flowing through this and current flowing through this are different. This will have the same current, but not as this much. So how do you treat these 2 as a series? Current through this and this are different. You can't treat them as series. And suppose in case, no sir, I hold it here and I connect the resistance in series and I replace them, and I am going to find out the resistance across A and B, but I hold it here and I do that. Now, okay, I will agree with your argument and I will proceed. You say that these 2 are in series, so you are going to find out the resistance between A and B, and you say that these 2 are in series. Okay, then shall I replace this R and R as 2R? Similarly, these 2 in series, R and R as 2R? right? This is 2R, this is 2R, and this 2R and 2R comes to C, and A is here, C is here. You say that you are finding the resistance between A and B, but you have lost B. Where is B now? B has come between these two, and you have replaced these two resistances as 2R. Now B has gone inside that 2R. Somewhere here you will get B in the middle of this resistor. Now what you will do for B now? You have lost it. That's what I told. If you are going to find out resistance across any 2 points, those 2 points shouldn't be lost at any cost. And those 2 points are always required to connect a battery across them. So with those 2 points in the diagram, look into the circuit. That is very important. In the beginning you will find to adjust your brain for all these explanations. But as you work out more and more and more problems, your brain itself will start training by itself, and your brain itself will start adjusting this one. Then after solving some 10 or 12 problems, suddenly when you look into a new circuit, your brain automatically adjusts into that circuit and it starts working out. So unknowingly it starts working out. That is what should happen here. It is like a puzzle. This is not a very great question. It is like a small puzzle. How do you look into the puzzle? That is very important. Okay, look into the circuit from A and B. Sir, if I lose D and C, oh, no problem. No problem at all, because you are going to connect battery here, not across A and C, A and D. You are connecting battery across A and B. So what is the resistance between A and B? So I have to retain A and B at any cost. Am I right? A and B shouldn't be lost at any cost. And these three come in series now, because the same current flows through these 3R. So this is like a chain, right? You can remove this chain and you can replace it by a single R. So these three resistors can be removed and that can be replaced by a single resistor, and you know that all are in series, R plus R plus R. So it is 3R, this is 3R, and this is R. So what is the resistance across A and B? 3R parallel R. So that implies R across A and B is R into 3R divided by R plus 3R, 4R. 3R into R divided by 3R plus R, 1R gets cancelled, answer is 3 by 4R, am I right? This is the resistance between A and B. Now for the same circuit, if the question is find out the resistance between A and C, okay? So if you find it difficult to write now along with my explanation, you can write it later. You can take the video back and you can watch it again, no problem. Now just listen. Suppose you can write it along with me, you can do that, no problem. Okay, I will rub it now. Or shall I write? Okay, I will rub it. Now suppose you are asked to find out the resistance between A and C. So this is 3 by 4R. Now, once you do that, now you must be able to do it mentally. R, 3R, 3R parallel R. 3R into R by 3R plus R. 3 by 4R. Finished. R between A and C. How much? Now these two are the points which are very important for us. Now last time all the three were in series. Now they are not, because you have to connect the battery between A and C. So you are asked to find out what is the resistance between A and C. That means you have to connect the battery here, right? Equivalent resistance between A and C. Suppose a battery is connected between A and C. How will the battery send the current? As soon as the current starts from here, it splits into two parts. One part moves up to here like this. Another part moves up to here like this. And current through this and current through this may be same or may not be same, depending on the resistance. But they are different branches. So you can treat these two as series, these two as series. So when you hold it across A and C, yes. Okay? When you hold it across, so now B is not important for us, D is not important for us. If it is held across A and C, hold it here. When you hold it here, can you remove this chain? You can remove this chain and you can replace it by a single resistor R here. I don't know what is that R, R plus R, 2R. You can remove this chain, this one. Sir, I lose D, no problem. You are asked to find out the resistance between A and C. Lose D, no problem. So remove this and replace it by a single resistance, 2R. This is 2R, this is 2R. So R across A and C will be, A will be here and this will be R plus R here on the other side. From this side is the R plus R again. So this is 2R, this is 2R. Here is C. You are asked to find out between A and C. Where is D, sir? D is inside this. Where is B, sir? B is inside this. Not of importance for us now. 2R parallel to R. Remember, if equal resistances are in parallel, then R by N. R in parallel, then R by 3. 5 R's in parallel, R by 5. 2 R's in parallel, 2 R by 2. Or you apply this formula. So we want the resistance between A and C, 2R into R, 2R divided by 2R plus 2R, and you must be able to do this a little bit faster later. It is 2R by 2. So here this is 4R, this answer. So 1 2R 2 times, 1 times, answer is R, 2R by 2. So between A and C, answer is R. It is R. Okay. So sir, what about other points? Suppose you are asked to find out between A and D. It is same as 3R by 4. Why? Resistance between A and D. Just simply look into this. Now your brain will start working out. If you hold it at A and D, that means you have to connect a battery across this. Now can you imagine that current through this and current through this are different? Same current flows through this and enters here. This current is different. So these three are in series. R plus R replaced into 3R. Across this, 3R parallel R, that is 3R by 4. 3R into R divided by 3R plus R. Is it so? What is the resistance between A and, so this is 3R by 4, correct? What about this? D and B, resistance between D and B. Is it same as resistance between A and C? Correct? You have to hold it here, connect a battery here, and then the current from positive splits into 2 like this, enters like this and like this. So these two are in series, these two are in series, 2R parallel to R, 2R parallel to R is 2R by 2 R. So resistance between D and B is R. So now you can have an idea. So now as soon as you get that picture, you will suddenly come to know how to get the answer, right? So that picture itself should give you the answer. Okay, now we'll move on to the next one, next diagram. Here is another circuit. You have resistances in values, numericals, and you have to get the equivalent resistance. And you have been asked to find out resistance between A and B. Say, first question is, what is the resistance between A and B? Again, the same thing. You have to assume that there is a battery between A and B and connect it across the circuit. Yes, A, and you have one more resistor here, like this, here, along the diagonal, and its value is 2 ohm, and the value of this is 6 ohm, and this is 3 ohm, and this is 1 ohm, okay? This is 1 ohm, and this is 2 ohm, and here is A and B. You have to connect a battery across this, like this. Then what the current flows through here will be different here, and it again splits into 2 here, and these two currents will join here, come here, and like this. Now the same current will flow through this and this, right? It doesn't split. That means these two are in series. They are in series. So again, we will have all types of discussion here. Sir, you say that these two are in series. Of course, I remove this and I can treat it as a different branch from here to here. I can remove this. So when this piece is removed and it is taken as a necklace, say, remove this, 6 plus 3, 9, right? Is it 6 and 3? Yes, 6 plus 3, 9. 9 parallel to, am I right? That 9 should come parallel to. Sir, when you are asked to find out the resistance across A and B, why can't I take 2 and 1 ohm in series? 2 and 1 ohm in series. Again, the same argument that we had earlier, because a lot of confusions will occur. I am going to find out resistance between A and B. I feel that I can treat 2 and 1 parallel, series. No, wrong. Why? When you replace 2 and 1 in series, what you will do? This 2 and this 1. This is B, A. And when you replace this 2 and 1 in series, 2 plus 1, 3, you will replace 3 ohm. Where you will place B? Sir, B is inside this. Then how will you find out the equivalent resistance? If point B is inside, it should be externally available. This can't happen. Now, in this situation, it is wrong. So A and B are not in series when you look into the circuit across A and B. Sorry, 2 and 1 ohm are not in series when you are looking at the circuit from A and B. Not possible. Hold it at A and B. At any cost, don't lose B. That means you have to restrict your view from here to here. Now, whether these two are in series are another confusion. These two, 2 and 1 ohm are in series. Sir, can I replace this 2 and 1 ohm as a 2 plus 1, 3 and then proceed? That is also a problem, because you see the circuit is like this. You proceed forward, then you will come to know that it is wrong. Okay. So like this, here is 1 resistance 2 ohm, and this is 6 ohm, and this is 3 ohm, and this is 1 ohm. Okay. Now I treat that, so again the resistance is between A and B. I treat that 2 ohm and 1 ohm are in series. Okay, I will give you the permission. You just replace this. You ask 3 ohm to stay back. Please stay back for some time, 3 ohm. Don't disturb us. Okay, 3 ohm stays back. And it was in connection with the C, remember. The other end of the 3 ohm is in connection with the C. This should go to C, right? It is to C. It says, please connect me again back to C, 3 ohm will say. Okay, now I will get back, but later on you connected me to C. Okay, we will agree, we will connect it to C. Replace this 2 ohm and C is here. Replace 2 and 1 in series with the 3 ohm. Okay, I will replace it with 3 ohm. Now where is C? 2 plus 1, this one. Where is C? C is somewhere in between, right? Because it is in the middle of 2 and 1. But now we have only 3 ohm. Where is C? Now where you will connect this one? Sir, we will connect it like this. Can't we connect it like this? Suppose this is 3 ohm, which is connected instead of 2 and 1. Can't I connect it like this in between? It is not a rheostat. It is a single resistor. You can't do it like this here. That's the problem. So if you treat that 2 and 1 are in series, in between you get a 3 ohm. When you replace these two by a single resistor, you can't connect it. Moreover, when you connect a battery here, the main actual argument is like this. They are not in series because, so when you connect a battery, so this is 1 ohm, this is 3 ohm, and this is 2 ohm. When you connect a battery here, if you want to treat 2 and 1 as series, same current must flow. It will never be the same current because current divides into 2 parts here. One part again goes out of this like this. That part moves through this. So current through these 2 resistors are same. They are in series, no doubt. But what current flows through here? That is not the current through 1 ohm. Current through 2 ohm will be less, and this current will join with the current through 2 ohm. Then it will move to 1 ohm. So current through 1 ohm and 2 ohm are not same. They are not in series. Then how is the solution, sir? You say that this is not the way, this is not the way. Then what is the way of solving this? Very simple. Now you might have come across which is wrong and which is right. Because I want to say what are the wrong things. Then we will come to the correct thing. Then you will come to know that this is itself is the correct way. A and B and 2 ohm, and this is 1 ohm, 6 ohm and 3 ohm. Right? Okay. So which will you treat as series, sir? Definitely. If you remove this chain and replace it by a single resistor, then it is of no problem, right? Because when you replace this by a single resistor, you will lose this point, but that point is of no importance for us. Remove this. 6 plus 3, shall I remove it? 6 plus 3, 9. Okay, then I have all the points as it is. So this is 6 plus 3 is equal to 9. Now which will you remove, sir? Sir, shall I replace 2 and 1 as series again? No, not at all. What will do with this 9 ohm? Where you will connect this 9 ohm? If you ask the 9 ohm to get back and then make it as 3 ohm, again connection becomes problem. And again, if you connect a battery here, definitely current through this will not be same, and current through this and this will never be same. But can I treat this parallel branch now? 2 and 9 parallel, yes, that is possible. And you can remove this chain 2 and 9 parallel and replace it by a single resistance. What is that? 9 and 2 parallel. 9 into 2 by 9 plus 2. I have taken some odd numbers, I get fractions, I think. Let it be. 9 into 2 is 18, this is 11, right? 18 by 11 ohm. So shall I replace this whole by 18 by 11, right? This resistor. So this is 2 ohm. And if you understand all these concepts, then you can solve the problem. So your brain should understand this, why it is so. And then the brain itself will start working. The 18 by 11, this 9 2 parallel branch, and this is 1 ohm, and this is A and B. See, we are not losing A and B at any cost. We are retaining A and B always. Okay. Now, what else you can do? Sir, what is the further movement? Shall I treat 2 and 1 in series? No, that is not possible. B is lost. No current, same current flows through 2 and 1. No same current. It's different current. So these two are in series now. Whatever the current flows to this, same current flows up to this. Now 18 by 11 and 1 are in series. So what is the equivalent? You find out the equivalent of this one. What is that? 18 by 11 plus 1, because they are in series. you remove this chain like a necklace, right? Remove that necklace, replace it by a costlier and beautiful necklace. 18 by 11 plus 1 is equal to 11 common denominator, 18 plus 11, right? 1 11s are 11. It is 1929 by 11. 29 by 11 is the resistance of this. So shall we replace it? Finally, I'll write it here. Finally, we have 2 ohm and this 29 by 11 ohm. So 2 ohm parallel 29 by 11 ohm. I have taken some odd numbers. I should have thought of while taking the numericals, but still it is not wrong. So what is the resistance between A and B? Finally, R across A and B is equal to, so we have not gone wrong, 9 into 2 divided by 9 plus 2, 18 by 11, plus 1, it is 11, 11, 29, 19, 29 by 11, parallel 2 ohm. So R across A and B is, I'll rub this, because this is already recorded in the video, you can rewind it and you can see. So R across A and B is equal to 29 by 11 into 2 divided by 29 by 11 plus 2. R across A and B is equal to, this is 58 by 11, R1, R2, R1 plus R2. This will be 22, that is 51 by 11. Am I right? This is 1 11s are 22 here, 11 2s are 22 plus 29, 31, 51. So this is 58 by 51 ohm. That is the final answer between A and B, across A and B. That is the final answer. Okay, same problem, points different. R across A and C. Now look into the circuit. What is the resistance between A and C? Now, you have to connect a battery across A and C. Am I right? Here. And now the current flows here. It splits into 3 parts. That means neither 2 ohm nor this set are in series. They are in parallel. Because current is splitting. Current splits when there is a parallel connection. And these 2 are in series because whatever the current flows through this, up to here it is same. Up to here it is same. So you are not having any responsibility about B now. B can be lost at any moment, no problem. You are not interested in B. So what I can do, sir? I can lose B but not C, because you have been asked to find out the resistance between A and C, right? A and C. So at any cost, don't lose A and C. If you hold it firmly, you can remove this and replace it by a single resistor. You can remove this, replace it by a single resistor, because A and C will be there only. So A, C, right? This is A and this is C. And that resistance is 2 ohm here. What about this one? Can I remove this? Yes, possible. It is series, 6 plus 3, 9 ohm. Of course, I have to connect it across A and C only, finally, when I remove this as 9 ohm. 6 plus 3, 9 ohm. What about the other side? Other side we have like this, 2 plus 1, 3 ohm. Sir, B is lost. Okay, let it be lost. We are interested in A and C. Now the 3 parallel. 2 plus 1, so we are holding it here. Current through this one, current through these 2 will be same, current through these 2 will be same again, this series, and all the 3 in parallel. So this is from 2 plus 1 is equal to 3. Now equivalent resistance is Rp, 1 by Rp is equal to, there are 3, I will use the same formula, 1 by 9 plus 1 by 2 plus 1 by 3. 1 by Rp is equal to, this is this which you can take common, 18 you can take common, 18, then 9 2s are 2, 2 9s are 3 6s are, am I right? 18 common, 9 2s are 2 9s are 3 6s are, 17 by 18. Remember, this is not the answer, this is 1 by Rp. Rp is equal to 18 by 17 ohm. See how you can do that. So looking into the circuit from different points and different terminals makes the result different. You must be very careful then. And if you are losing other nodes, no problem at all. You must be taking care of those 2 nodes where you are going to connect the battery or where the equivalent resistance is asked. Okay, again if you look into, before going to that Wheatstone's network, we will see one more circuit. Then we will go to the Wheatstone's network. Then we will have some questions in the that PPT. which will help you to get the answer very easily. And all these circuit diagrams with the printed on the paper, I will send you the PDF. You can study that later. Okay? Right. Now we will see. Yeah, we will have a new problem then. Now, suppose you have resistors like this, and like this. And here is a resistor from here to here, say, like this. Now, say this is 6 ohm, and this is 4 ohm, and 2 ohm, and 3 ohm. Say this is A, this is B, and I will say this is C. I want one more point at C. Now things become very easy when you select A and B. R across A and B. What is the resistance across A and B? What you have to do? Connect a battery across this. You have to imagine that, that's all. Current flows through this, but splits into two. But these two will get the same current, their own current. Whatever current enters here, enters to this. So whether this part is in series when you consider A and B, and you are not going to lose B also, because B doesn't come here. When you replace this as 6, result of these two, 4 plus 2, B has no problem. So shall I replace these two as series? Okay, I can do that. Sir, why can't I treat 4 ohm and 3 ohm as parallel? No, 4 ohm, the two ends of the 4 ohm are not connected to the two ends of 3 ohm. One end is common, but what about this end? It is not common, so that is not possible. So shall I write the equivalent circuit? Then this is 6 ohm, this is A, and here is 4 ohm plus 2 ohm, 4 plus 2, that is equal to 6 ohm, R1 plus R2. Then for the whole 6 ohm, this is 3 parallel, so 3 ohm parallel, okay, and this is B. Okay, now, right, and what else, sir? So this is 6 ohm. What is the next step? Shall I treat 6 ohm and 6 ohm in series? No, not possible. Again, the battery will be connected here only. Current will be flowing like this. It splits into two. Current through this and this are not the same, but they are in parallel. So can you replace this parallel combination? I will replace this parallel combination. 6 into 3 divided by 6 plus 3, that is equal to 18 by 9, that is equal to 2 ohm, right? So that is this part, that is 2 ohm. Okay, this whole part is 2 ohm. So shall I replace that whole part by 2 ohm, 6 ohm, and 2 ohm, and B, AB. So 6 plus 2, 8. So R through A and B is 8 ohm, correct? 6 parallel 3, 2, 6 plus 2, 8. That is all the thing. So that is the resultant. Now, this is the easiest one. What about across A and C if it is asked? That is most interesting. Now you should be very careful. What is the resistance across A and C? I'll rub this. Okay. Resistance across A and C. R across A and C. That is equal to, okay, how much? Now you have to connect a battery across A and C. The circuit is shown in such a way that it is very difficult to imagine it between A and C. Very difficult. Now I say that 3 and 2 ohm are in series. Do you agree? 3 ohm, 2 ohm are in series. Are you ready to agree? They are. They are in series. How, sir? From the positive of the battery, current flows like this, and it splits into two parts here. That current splits into two parts. The negative of the battery is here, you see. This current flows like this, and there is no path here further. It should flow like this. Whatever the current flows through 3 ohm must flow through 2 ohm. There is no path here, because B is open now. Battery is connected between A and C. A and C is the point which is of interest now. So current, once it splits, once it enters through 6 ohm, once it splits, one of the current flows through 3 as well as 2. They are in series. Or, if you don't understand it so now, I will show it by an equivalent circuit. Okay, I will round it up. The resistances are like this. This is okay. There are different resistances here. Their names and values itself are different. So I don't want to give some colors or so. 6 ohm. Where is A? A is here. I will draw it like this, and then 4 ohm. Okay? 4 ohm, one end is at C, right? C. Now what I'll do is, I'll pull this wire. When I pull this wire, this resistance comes to this side and this goes up, C goes above. Can I do that? But this end is between 6 ohm and 4 ohm. So from here starts. When I pull this wire, I'll pull this wire. I'll pull this wire and stand here and I keep on pulling this wire. When I pull this, what will happen? 3 ohm will come like this. It will come a little bit nearer, right? It will come like this. This part will be lifted up and it will go like this. So it is like this, and B will be somewhere here. This will be connected. Don't you think so? It will happen like this, right? But B is of no importance for us, so don't write it at all. Or if you want to write it, okay, write it here. No problem. B is not needed. You are asked to find out the resistance between A and C. So I will stand here and I will pull it. When I pull it here, this point gets raised and this point comes to this one. Now I will write it again. A little one, changed one, 4 ohm. And this one is 2 ohm. 2 ohm, from 2 ohm to B, B to 3 ohm, 3 ohm to this point. I will name this point as something like D. So D is here. Is it right? Now, A is here, C is here, D is here. Now, shall I write this as 3 ohm and 2 ohm and 3 ohm, and here is B. Again, I pull it a little bit. So again, I am very free and I can pull it as much I can do. I go on pulling it. B comes to the top. Now, are they in series? Can you imagine this circuit in this form? That is what you have to do. This imagination, that animation should come in your brain. That you will definitely get it. You won't think that, sir, how can I understand all those things? Is it possible? No, everybody can do that. If you have brain, definitely you can do this. Only the thing is, you have to train your brain. Your brain is already created by God. Training is left to you. That is what you have to do. So keep on doing it yourself, and once you do this diagram, your brain itself will start giving the video. By itself it will start thinking, and this resistor going up and it's coming like this, and 3 ohm and 2 ohm in series. So when you are finding the resistance across A and C, you will connect a battery here. Now this path becomes an independent path. That means resistance through these two paths will be same. So they are in series. Now you can proceed forward, and even D is of no importance for us. So which will you replace first? Whether it is 3, 2 in series or 4 and 2 in parallel. You know, 3, 2 in series. So what is the equivalent? Equivalent resistance circuit is A here, 4 ohm here. So this is, what is the first one? 6 ohm, right? 6 ohm here, and A here, D here. And what about the other one? 4 ohm. And across 4 ohm, you have 3 plus 2, 5. So here you have 3 plus 2, 5 ohm in parallel. Now, 5 and 4 are in parallel first. So A here, then 6 ohm here, and 5 and 4 in parallel. So this is 5 into 4 by 5 plus 4. What is this? 5 and 4 in parallel. Is it so? 3 plus 2, 5? Yes. That is 20 by 9 ohm. Now what is the final answer? 20 by 9. So here is B. No, that is what is required now. C, isn't it? C, here is C, here is C, because the other end of the 4 ohm is C. So what is RAC? RAC is these two resistances added. This one plus this one. This one is 20 by 9 ohm. This is 6 ohm. So 20 by 9 plus 6, that is equal to 9 common, 20 plus, this is 1 za, 1 9 za, 54. So what is the answer? 74 by 9 ohm. This is not 1 by RC, this is RAC itself. So 74 by 9 ohm. That is the answer. Hope I am right. Yes, between A and C. It's 5. Then 5 into 4 divided by 5 plus 4. That is 20 by 9. 20 by 9 plus 16. 54. 1 9 za. Yes, correct. 74 by 9 ohm. That is how we have to do. So looking into the circuit from a particular points, the nodes is very important. Now we will go to the last one, that is this one. Then we will go to PPTs from the next class. This one, Wheatstone's network. You know that Wheatstone's network, if it is balanced, say all the resistors are R's, R, and R. If it is balanced, then this resistance by this one are equal. Any Wheatstone's network is said to be balanced if the ratio of R1 by R2, R3 by R4, or this one by this one, and this one by this one, or this ratio, or this ratio, anything, any adjacent ratio in the same manner. For example, this divided by this, if you take, same ratio here. This one, same ratio, but not opposite. Opposite resistors ratio shouldn't be considered. If they are same, the bridge is said to be balanced. Now, this bridge is balanced because R by R is equal to R by R. It is 1 equal to 1. So it is already balanced. Now how to find out the equivalent resistance between A and B? Very simple. When the bridge is balanced, no current flows through these two parts. So I will call it as C and D. No current flows through this. You know this. You have proved this, right, in using Kirchhoff's laws. No current flows through this. So can I remove that path? You can remove it. And what is the equivalent resistance? Equivalent resistance is, now you can do that across A and B's. This is series, this is series. So you can't treat these two as series. Why? Because A comes into picture here. If you connect a battery here, definitely the two sets of resistors which enjoy the same current are this one and this one, and this one and this one. So they are in series. So 2R parallel 2R, 2R parallel 2R is 2R by 2, or 2R into 2R divided by 2R plus 2R, that gives you R answer. So remember, even in capacitors, the answer is same. If if 4 resistors are equal value are forming a Wheatstone's bridge, it is balanced, then no current flows through in the galvanometer path, then the equivalent resistor is R. Okay, that point you have to remember. Whatever the individual values are, same answer you will get. If all the resistances are 2 ohms, answer is also 2 ohm. And another point you have to remember is, in one of the previous classes I have mentioned it, if it has to be a Wheatstone's bridge, and the fifth one, what is in the galvanometer, should be in the 2 vertices which are not used by the battery. And if you connect the 5th resistor here, it is not a Wheatstone's bridge. One of the opposite corners of the quadrilateral must be connected to the galvanometer, and remaining 2 opposite corners must be connected to the battery, and equivalent resistance must be asked between those 2 corners where you are going to connect the battery, where you assume the battery is connected. Across those 2 points you are finding the equivalent, and remaining 2 points will be connected to the galvanometer or in a 5th resistor. Now this can be understood by another idea. This can be understood in another idea. How? Suppose you have a Wheatstone's network, any network for that matter, need not be only Wheatstone's network, but I will explain it using Wheatstone's network so that you can remember it easily. And don't make it like a notes or points. You must be able to remember it easily by your own concepts, right? You must be able to remember it by your own general knowledge. So if it is like this, so this is a resistor, this is a resistor, here is one more resistor, and like this. Okay. Now, this is A, this is B, say. This is C, this is D, and here is also one more resistor given. All are R's. And you know that it is already balanced. Since you are going to connect battery here, no current flows through here. Suppose you connect this R here and battery here, then no current flows through this side, right? Can you imagine that? Suppose it is like this. The Wheatstone's bridge is like this. If it is like this. And if you are going to connect the battery here and here, and if the resistance is given here, then also it is a Wheatstone's bridge. All the thing is you have to turn this, you will get this diagram. Now my question is, can't you analyze it in a different way? Yes, possible. Now this is a mirror symmetry problem. What do you mean by mirror symmetry? If you draw a line axis like this, the circuit is symmetrically equal on either side. Whatever the objects you have a mirror image inside. So if you have such a circuit where one part of if the whole circuit can be divided into 2 parts, where left part forms the object and the right part forms the image, if it is mirror symmetrically on either sides, even this resistor is symmetrically on either sides, no problem. Then if you can, where you will put the mirror so that it is symmetrical on either side, this is the axis where you put the mirror. So this is symmetrical axis, and I call this as a vertical axis because you are going to find out the resistance across A and B, and this mirror comes perpendicular to A and B, right? If your axis is a vertical axis to the points where you are finding the equivalent resistance, then all the points which come along with the mirror, these 2 points, are at the same potential. You know this, right? In a Wheatstone's network, if the resistances are balanced, R1 by R2 is equal to R3 by R4, no current flows through the galvanometer. What do you mean by that? The potential here and potential here are same. What do you mean by potential same? No, the work done to take the charge from here to another point, and work done to take the charge from here to at the same point are same. That means no work has to be done from while taking the charge from here to here. Potential here and potential here are same. No potential difference. I didn't say there is no potential. I said there is no potential difference. Charges flow only when there is a potential difference. Heat flows when there is a temperature difference. There is a potential, but they are same. No potential difference, no current flows through this. So, if you can divide a circuit by placing a mirror and one half and another half are symmetrical images, then how did you place the mirror? How did you draw the axis? If that axis is vertical to the points where you are finding the equivalent resistance, then all the points coming on this axis, on the mirror, are having the same potential. This one, same potential. No current flows through them, same potential. Okay? Okay, that is one thing. Sir, can't I divide this Wheatstone's bridge into 2 symmetrical image parts? Suppose this is a Wheatstone's bridge. Can't I divide this Wheatstone's bridge by drawing an axis like this? So A and B are here. Can't I divide this by drawing an axis and like this? Yes, possible. Of course, this resistor also should get half here and half here, right? It is also divided into 2 equal parts. Now, whether this part of the circuit and this part of the circuit, won't they form mirror images? Yes, they form. But where is the axis now? Axis is along the points where it is connected. Where the resistances are asked. It is along the points. So I call this as parallel axis, and I call this as vertical axis or perpendicular axis. What do you mean by parallel and vertical or perpendicular? Parallel in the sense the axis which is parallel to the points which you are going to find out the resistance. Perpendicular means the axis which is perpendicular to the points where you are going to find out the equivalent resistance. So if the axis is parallel, then the points which are coming on the either sides of the axis will have the same potential. If the axis is vertical to the points where you are going to find out the equivalent resistance, then the points along the axis will have the same potential. That is the difference. Got it now? You just remember this. You know where the potentials are same. That you know. Here the potentials are same. Now if you are dividing the whole circuit along like this, which is perpendicular to the resistance finding points, then the points coming along with the axis will have the same potential, and points coming on either side of this parallel axis will have the same potential. So this is the way. Then we will take some problems and we will solve it. Okay? And this is the way in which we have to consider it, and then we can reduce the circuit easily, and you can remove them, and if the potentials are same, you can remove those 2 points and you can find out the equivalent. This is the basic idea that you must need, and we will go to the complicated problems by using the PPTs, and that will be more useful. So have these ideas in your brain, and let us meet in the next class, right? And we will go with more and more problems. Have a nice time, and work out more problems yourself. Be cheering, be happy. Thank you for watching.